I'm Rachel and I'm an engineer. And the hardest problem I know of isn't sending a rocket to Mars, or curing cancer, or solving climate change. It's picking a strawberry. All of the fruit in this box is picked by hand. It's March here in the UK, and this fruit has travelled thousands of miles from Spain, where it was picked by a person, because we have not yet invented a machine that can do this simple task. This machine identified my item, it weighed my shopping, it took my payment by reading a note, gave me the correct change, and it's even filming me to make sure I don't steal. But the thing I just bought, it couldn't have picked it. In the UK, strawberries grow in the south between about May and October. This short growing season means that most of the year they need to be imported from places that are warmer by plane or by boat, places like Spain, Morocco and Egypt. Come summer, farms across the UK will need around 70,000 people just to bring in the harvest by hand. And every year that number gets harder to find, meaning many tons of fruit just goes to waste. Your hand contains around 17,000 nerve endings. It adjusts its grip in milliseconds. But rigid? Rigid just doesn't work. It's also a problem that every berry is different. No two are the same, so we need something infinitely adaptable. Nature solved this problem millions of years ago. An octopus arm has no skeleton, no rigid parts. It wraps, it holds without crushing because the pressures spread across the whole surface rather than concentrated at a single point. This flexible arm was developed by a team at the University of Science and Technology of China. I've 3D printed a copy, layer by layer, from a digital blueprint. The same printer that makes hard plastic can also produce something that moves like a living thing. It works like the tendons in the hand. When you pull, that grips, but when it releases, that relaxes. This spiral arm works the same way, with 2 strings, each of which would be pulled by a motor. Soft robotics like this could be really useful for farming, harvesting around the clock, whatever the season. Robot-assisted surgery could really help, freeing surgeons for more patients, shorter waiting lists, not replacing doctors, but extending what they can do. Soft robotics could assist in routine care that doesn't tire, doesn't leave, doesn't burn out, in going into places which are too dangerous or too inaccessible, finding survivors where humans can't reach, and saving lives. The engineers developing technologies like this, they aren't just solving a farming problem. They're teaching machines something remarkable. How? To be gentle. And that changes everything. We are only at the very beginning of knowing what soft robotics can do. And the person, the engineer, that figures out the next piece of the puzzle, that could be you.